What if everything you think you know about human history is wrong? What if the story we tell ourselves about being the first intelligent civilization on Earth is just comforting fiction? What if thousands, maybe millions of years before the first pyramid was built, before the first word was written, entire civilizations rose to incredible heights and then vanished so completely that we walk over their remains without ever knowing they were there? This isn't science fiction. This isn't some wild conspiracy theory. This is a question that's starting to keep serious scientists awake at night. Because when you really look at the numbers, when you step back and consider just how old our planet actually is, a disturbing possibility emerges. We might not be the beginning of the story. We might just be the latest chapter in a book that's been written and rewritten more times than we can imagine. Think about it this way. If the entire history of Earth were compressed into a single year, humans wouldn't appear until the last 2 minutes of December 31st. Our entire recorded history, everything from ancient Egypt to the smartphone in your pocket, would happen in the final few seconds. That leaves 364 days and 22 hours where something else could have happened, where someone else could have been here. The math is staggering. Earth is 4.5 billion years old. Complex life has existed for over 500 million years. But humans, we've been around for maybe 300,000 years, and we've only had what we call civilization for the last 10,000. We've had industrial technology for less than 300 years. In geological terms, we just got here. We're not even a footnote yet. So, here's the uncomfortable question nobody wants to ask. In all those billions of years, in all those vast stretches of time when conditions were suitable for life, when oceans flowed and climates were stable, is it really so impossible that intelligence emerged before? That some other species, following a different path, reached heights we can barely imagine, and then disappeared into the mists of deep time? The idea sounds crazy until you realize how little we actually know about the deep past. The fossil record isn't a complete history book. It's more like scattered pages from a story that's been mostly destroyed. Most life that ever existed left no trace at all. Most environments, most ecosystems, most entire worlds have vanished without a single clue they ever existed. We build our understanding of history on what survived, not on what actually happened. And what survives is determined by luck, by geology, by chance. The creatures that fossilized well, the rocks that didn't get crushed or melted or buried, the tiny fraction of evidence that happened to make it through billions of years of earthquakes, volcanoes, erosion, and continental drift. When paleontologists find a new species, they're not discovering something that was common. They're finding something so rare, so incredibly lucky to be preserved, that it's almost miraculous it exists at all. For every fossil we find, millions of species lived and died without leaving so much as a single bone behind. Now imagine trying to find evidence of intelligence in that same framework. Intelligence doesn't fossilize. Cities crumble. Metal corrodes. Even our most durable creations would be unrecognizable after just a few million years, let alone hundreds of millions. The pyramids, which feel ancient to us, are newer than the grass beneath your feet in geological terms. If human civilization ended tomorrow, what would remain after 10 million years? Some synthetic chemicals in the soil, a few strange isotope signatures, maybe some oddly shaped rocks that used to be buildings, but nothing that would obviously scream intelligence to a future archaeologist. Nothing that would say we were here, we built cities, we reached for the stars. And that's the terrifying beauty of this possibility. An advanced civilization could have existed, could have thrived, could have achieved things that would make our technology look primitive, and then vanish so completely that we'd never know they were here. Not because they weren't advanced enough to leave lasting monuments, but because time itself is the ultimate destroyer of evidence. Consider the forces working against preservation. Plate tectonics constantly recycle the Earth's surface. Ocean floors disappear into the mantle. Mountains rise and erode back to sea level. The land we're standing on today might have been at the bottom of an ocean 100 million years ago, or it might be there again in the future. Any civilization that built on that land would be gone, not just forgotten, but physically erased from existence. Then there are the mass extinctions. 5 times in Earth's history, catastrophic events have wiped out most life on the planet. The asteroid that killed the dinosaurs was just the most recent. Before that, volcanic eruptions, climate shifts, and other disasters regularly reset the biological clock. Each time, evolution started over with whatever managed to survive. But here's what's really unsettling. Those extinction events didn't just kill species. They erased entire branches of the evolutionary tree, whole ways of being intelligent, whole approaches to consciousness and technology that we'll never know about because they're gone forever. What if one of those lost branches had figured out something we haven't? What if they developed not just intelligence, but wisdom? What if they learned to live in harmony with their environment instead of dominating it? What if their technology was so advanced, so integrated with natural systems, that it left no trace behind when they were gone? Or maybe they saw what was coming. Maybe they had enough warning about the asteroid, or the volcano, or whatever disaster was approaching to prepare. Maybe they didn't fight it. Maybe they accepted their fate and chose to disappear gracefully, leaving the planet clean for whatever came next. These aren't just wild speculations anymore. In recent years, serious scientists have started asking these questions. There's even a name for it now. The Silurian hypothesis, named after a fictional reptilian species from an old science fiction show. The idea is simple but profound. If an industrial civilization had existed millions of years ago, would we be able to detect it today? The researchers who proposed this weren't claiming that such a civilization actually existed. They were asking something more fundamental. They were asking whether our methods for studying the past are even capable of finding something like that, whether the tools we use to understand Earth's history would recognize the signatures of ancient intelligence if they were staring us in the face. And the answer they came up with was deeply uncomfortable. Maybe not. Maybe we wouldn't see it at all. Because we're not just looking for evidence that's hidden. We're looking for evidence that might not exist anymore. We're trying to read a book that's been torn apart, burned, scattered to the winds, and buried under miles of rock. We're trying to hear an echo that's been bouncing around for hundreds of millions of years, getting fainter and more distorted with each repetition. But sometimes, if you listen carefully, you can still hear something. A whisper in the geological record, a strange pattern in the chemistry of ancient rocks, an anomaly that doesn't quite fit the models, a signature that looks almost like it might have been left by something that was thinking, planning, building. These signals are subtle. They're easy to dismiss. They're often explained away as natural processes, as quirks of geology or biology. But they're there, and they're starting to accumulate. Strange concentrations of metals in ancient sediments, isotope ratios that don't match what we'd expect from purely natural processes, chemical signatures that look suspiciously like the kind of pollution an industrial civilization might leave behind. carbon spikes that resemble what we're creating right now by burning fossil fuels. None of this is proof. None of it is a smoking gun. But it's enough to make you wonder. It's enough to make you look at the deep past with new eyes and ask whether the silence we hear when we listen to those ancient rocks is really emptiness, or whether it's just the sound of something so old, so distant, so completely erased that we've forgotten how to recognize its voice. Because if we're not the first, if intelligence has risen before, then everything changes. Our place in the universe, our understanding of what's possible, our assumptions about what the future holds. We're not the pioneers anymore. We're not the first to ask these questions, to wonder about our place in the cosmos, to reach for something beyond ourselves. We're just the latest in the long line of minds that have looked up at the stars and wondered if anyone else is out there, never realizing that the answer might be buried right beneath our feet. The evidence is hiding in plain sight, scattered across the planet in forms so subtle that we walk past them every day without recognition. Deep in the ancient rocks of South Africa, miners have discovered perfectly spherical metal objects with precise grooves carved around their circumference. They're found in rock layers that are nearly 3 billion years old, from a time when Earth supposedly hosted nothing more complex than primitive bacteria. The official explanation is that these are natural formations created by mineral deposits under extreme pressure. But the precision is unsettling, the symmetry too perfect, the grooves too evenly spaced. Nature creates order, yes, but this kind of mathematical perfection, it makes you pause. It makes you wonder what else we might be missing. In coal mines across Europe and North America, workers have reported finding metal objects embedded in coal seams millions of years old. A brass bell in West Virginia, an iron pot in Oklahoma, a metallic chain in Illinois. Each discovery dismissed as contamination, as objects that somehow migrated from more recent layers. But the coal around them shows no signs of disturbance. The objects are fused into the rock as if they've been there since the coal first formed. These aren't isolated incidents. They're part of a growing catalogue of anomalies that don't fit our timeline. Objects that shouldn't exist, structures that seem too organized, patterns that look designed rather than accidental. Take the ancient stone walls found in remote corners of the world. Massive blocks fitted together with such precision that you can't slide a knife blade between them. No mortar, no cement, just stone against stone with tolerances that would challenge modern engineering. The conventional explanation is that ancient humans were more skilled than we give them credit for. But some of these structures are found in layers far older than any known human civilization. Or consider the geopolymers, synthetic stone-like materials that shouldn't exist in nature, but show up in ancient rock formations. Chemical compositions that require controlled manufacturing processes. Molecular structures that mirror modern cement technology. Found in geological contexts that predate human industry by millions of years. The most intriguing evidence might be chemical, carbon isotope ratios in ancient rock layers that match the signature of massive fossil fuel burning. Spikes in atmospheric carbon that happened long before plants even existed, let alone formed the coal and oil deposits we burn today. These events are usually attributed to volcanic activity or asteroid impacts, but sometimes the timing doesn't align. Sometimes the chemical fingerprint is wrong. Scientists have identified more than 20 major carbon anomalies in Earth's geological record. Most have explanations. Supervolcanoes, methane releases from destabilized ocean sediments, asteroid impacts that triggered global wildfires. But a few remain mysteries. Events that pumped carbon into the atmosphere in patterns that look eerily similar to what industrial civilizations produce. The Paleocene-Eocene thermal maximum stands out. 56 million years ago, something released massive amounts of carbon into Earth's atmosphere over just a few thousand years. The planet warmed rapidly, ocean chemistry changed, species went extinct. The event looks almost identical to what we're doing right now with our fossil fuel emissions. The leading theory involves methane hydrates, frozen deposits on the ocean floor that destabilized and released their carbon into the atmosphere. It's plausible, it fits the evidence, but the speed of the release troubles some researchers. Natural processes usually work slowly. This event happened fast, almost as if something was actively pumping carbon into the air. Could it have been industrial? Could some ancient civilization have burned their way to extinction, leaving behind only a chemical signature in the rocks? The idea sounds far-fetched until you realize that if our own civilization ended tomorrow, the main evidence of our existence would be exactly this kind of carbon spike. Future geologists, examining our rock layers millions of years from now, would find elevated levels of carbon dioxide, strange isotope ratios, and traces of synthetic chemicals. They might wonder what natural cool disaster have caused such rapid atmospheric changes. They might never suspect intelligence. This is the challenge of deep-time archaeology. We're not looking for artifacts in the traditional sense. We're looking for chemical ghosts, isotopic whispers, molecular shadows cast by processes that ended long before the first dinosaur drew breath. The search requires new tools, new ways of thinking. Instead of hunting for fossilized bones or ancient pottery, researchers examine ice cores for atmospheric anomalies. They study sediment layers for unusual metal concentrations. They analyze mineral formations for signs of artificial synthesis. Some of the most promising evidence comes from rare earth elements. These metals are essential for modern technology, but occur naturally in very specific ratios. When you find them concentrated in unusual ways, it suggests extraction and processing, mining and refining. Ancient rock formations in several locations show rare earth signatures that don't match natural deposits. The elements are there in the right quantities for technological applications, but in the wrong proportions for geological formation. As if someone had extracted them, used them, and left behind the waste products. The patterns are subtle enough that they could be natural, unusual, but not impossible. But when you find the same signatures in multiple locations, in rock layers of similar age, separated by thousands of miles, coincidence becomes less likely. Then there are the microscopic spherules, tiny glass beads found in certain ancient sediments. Most are clearly natural, formed when asteroids vaporize upon impact with Earth's atmosphere. But others are different. Their chemical composition suggests artificial origin. Their distribution patterns don't match impact events. Some contain metals that don't occur naturally in those combinations. Others show evidence of controlled cooling, as if they were manufactured rather than formed by random cosmic violence. They're found in layers that correspond to no known asteroid impacts or volcanic eruptions. Could they be the remnants of ancient industry? Microscopic debris from manufacturing processes that we don't recognize because they're so far removed from our own technology. The spherules are too small and too scattered to prove anything definitive, but they're consistent with the idea that someone, somewhere, was making things long before we learned how. The most unsettling discoveries come from the deep ocean. Sonar surveys have revealed structures on the seafloor that look geometric rather than natural, straight lines where there should be curves, right angles in formations that should be random, patterns that suggest planning rather than accident. Most are dismissed as unusual but natural rock formations. Underwater landslides that happen to create linear features. Volcanic activity that produce geometric shapes through some quirk of physics. But a few resist easy explanation. The Bimini Road in the Bahamas is perhaps the most famous. A series of rectangular stones arranged in what looks like a causeway or foundation. Mainstream archaeology attributes it to natural beach rock formation, limestone blocks that cracked along regular patterns as they hardened. But the alignment is suspiciously straight. The joints between blocks are too neat, and similar formations have been found in other locations, always in shallow water, always with the same geometric precision. These underwater anomalies might be coincidence. Natural processes can create patterns that look artificial. But the ocean floor preserves things that would be destroyed on land. If ancient civilizations built near coastlines, as most modern cities do, rising sea levels would have submerged their remains long ago. What we're seeing might not be ruins in the traditional sense. These could be the bones of civilizations, stripped of everything recognizable, reduced to their most basic structural elements. The geometric shadows of intelligence, preserved in stone and sediment. The evidence forms a pattern, not of proof, but of possibility. Each anomaly alone can be explained away. Together, they suggest something more intriguing. A whisper of intelligence echoing through deep time, distorted but not quite silenced. We may never find the smoking gun, the undeniable artifact that proves we're not the first. Deep time is too destructive, too thorough in its erasure. But the whispers are there, embedded in the chemistry and geology of our ancient planet. And if you learn to listen for them, if you know what signatures to look for, the silence of the deep past begins to sound different. Not empty, but full of secrets we're only beginning to decode. The silence isn't complete though, because buried in the fossil record, scattered across museums and university collections around the world, are specimens that don't quite fit. Fossils that make paleontologists scratch their heads and quietly file them away under labels like problematic or unclassified. Shapes that look too organized. Structures that seem engineered rather than evolve the ed. Tachidiacaran biota, some of the oldest life forms ever complex discovered. These creatures lived over 570 million years ago, long before anything resembling modern animals existed. But they don't look like early attempts at life. They look alien, geometric. Some are perfectly symmetrical, with fractal patterns that repeat at multiple scales. Others resemble circuits or mechanical components more than biological organisms. For decades, scientists have debated what these creatures were. Plants, animals, something else entirely. Many show no signs of having mouths, digestive systems, or reproductive organs. They existed in ways that don't match any known form of life. And then, as suddenly as they appeared in the fossil record, most of them vanished without leaving descendants. Were they evolutionary dead ends? Failed experiments in early biology? Or were they something more sophisticated than we're willing to consider? Life forms that operated on principles we don't understand, using energy sources we haven't discovered, following rules that died out with them. The conventional explanation is that they represent an early branch of life that went extinct when more familiar forms of biology took over. But what if it's the reverse? What if these geometric, organized, almost technological-looking fossils are the remnants of something that had already figured out intelligence, only to be wiped out by the chaotic emergence of primitive animal life? It sounds impossible until you consider the timeline. The Ediacaran period lasted for nearly 40 million years. That's longer than the dinosaurs ruled the Earth. It's more time than mammals have existed. 40 million years is enough for evolution to work miracles, to produce complexity we can barely imagine. During that vast span, while these strange geometric creatures populated the oceans, Earth was quiet, peaceful. There were no predators, no competition, no evolutionary arms race driving rapid change. Just stable conditions and endless time for whatever intelligence might emerge to develop and flourish. And then came the Cambrian explosion. 540 million years ago, life suddenly became violent. Predators appeared. Hard shells evolved. The peaceful Ediacaran world was shattered by tooth and claw. Most of those strange geometric creatures disappeared forever, their secrets buried under layers of more familiar fossils. But scattered throughout later rock formations are other anomalies. Fossils that don't belong where they're found. Structures that look manufactured. Objects that seem to have been shaped by intention rather than chance. There are the grooved spheres, metallic balls with perfectly parallel lines carved around their circumference. Found in rock formations across multiple continents, always in layers far too old for human technology. Each one dismissed individually as a natural formation, but taken together, they form a pattern that's harder to explain. The spheres vary in size, but maintain consistent proportions. The grooves are always evenly spaced, always parallel, always precise to a degree that would challenge modern manufacturing. They're found in rocks from South Africa, Ukraine, and the Western United States. Different continents, different geological contexts, but identical design principles. Natural formation of such objects requires specific conditions. Mineral deposits under extreme pressure, crystallization processes that produce geometric shapes, chemical reactions that create spherical forms. But the global distribution doesn't match known geological processes. The age ranges span hundreds of millions of years, and the mathematical precision remains unexplained. Then there are the polystrate fossils, organic remains that extend through multiple rock layers representing millions of years of geological time. Trees that somehow remained standing while sediments accumulated around them for eons. The conventional explanation involves rapid burial during catastrophic floods, quick enough to preserve the organic material before it could decay. But some polystrate fossils show signs of artificial modification. Cuts that look too clean to be natural breaks, holes that seem deliberately drilled, markings that follow geometric patterns rather than random damage. These features are usually attributed to later intrusion, contamination from more recent periods. But the surrounding rock shows no signs of disturbance. Most intriguing are the trace fossils, preserved evidence of ancient behavior rather than ancient bodies. Footprints, burrows, feeding marks left by creatures long dead. The vast majority are exactly what you'd expect from primitive organisms following simple survival instincts. But occasionally, researchers find traces that suggest something more complex, patterns that look planned rather than random, structures that seem to serve purposes beyond immediate survival, arrangements that suggest foresight, organization, perhaps even cooperation on scales that shouldn't have been possible for the creatures that supposedly made them. These anomalous traces are found in rock layers spanning hundreds of millions of years. Some predate the evolution of complex nervous systems. Others appear during mass extinction events when survival should have been the only priority. All of them challenge our understanding of when intelligence first emerged on Earth. The patterns become more intriguing when you consider what's missing from the fossil record. The absence of intermediate forms that should exist if evolution proceeded gradually. The sudden appearance of complex structures without simpler precursors. The gaps where millions of years of evolutionary history simply vanish from the record. These gaps aren't unusual. The fossil record is notoriously incomplete. Most of what lived left no trace at all. But some gaps seem too convenient, too perfectly placed. They occur at moments when something significant should have been happening, when major evolutionary transitions were underway. What if those gaps aren't empty? What if they're hiding evidence of development that followed different rules? Intelligence that emerged through pathways we don't recognize, using materials that don't preserve well, following principles that don't match our models of how consciousness should evolve. The search for these hidden chapters requires new approaches. Instead of looking for familiar forms of technology, researchers are beginning to search for unfamiliar signatures. Chemical traces that suggest controlled processes rather than random reactions. Isotopic patterns that indicate selection rather than chance. Molecular arrangements that imply design rather than accident. Some of the most promising evidence comes from studying how natural processes create order. Crystals form geometric shapes, but within predictable parameters. River systems branch in fractal patterns, but follow consistent mathematical rules. Biological structures show remarkable organization, but always serve clear survival functions. When you find patterns that exceed these natural limits, that show more organization than physics requires or biology needs, you might be looking at something else. Evidence of intelligence working within natural systems, using the same materials and processes, but directing them toward purposes that pure chance wouldn't achieve. The key is learning to distinguish between order that emerges naturally and order that's imposed intentionally, between complexity that arises from simple rules repeated over time and complexity that requires planning, foresight, and conscious design. This distinction becomes crucial when examining certain geological formations that seem too perfect to be entirely natural. Rock layers with mathematical precision in their thickness. Mineral deposits arranged in patterns that match technological applications rather than geological processes. Crystal formations that show signs of controlled growth rather than random development. Each example alone can be explained by natural processes pushed to their limits. But the accumulation of such examples in specific time periods, their geographic distribution, and their consistent mathematical properties suggest something more systematic at work. The evidence doesn't point to cities or machines in any form we'd recognize. Instead, it hints at intelligence that worked with natural processes rather than against them, technology that enhanced geological and biological systems rather than replacing them, civilization that integrated so completely with its environment that separating artificial from natural becomes nearly impossible. This kind of intelligence might leave traces we're only beginning to understand how to read. Signatures embedded in the very structure of ancient rocks and fossils. Patterns that look natural at first glance, but reveal deeper organization when examined closely. We're not searching for artifacts anymore. We're searching for artistry, evidence that someone, long ago, learned to sculpt with time itself. The more you dig into these anomalies, the more unsettling the picture becomes. Because if intelligence did exist in Earth's deep past, it might have operated on principles so foreign to our understanding that we wouldn't recognize it, even if we were staring directly at it. Consider how different our own technology has become in just the last century. A smartphone would be incomprehensible to someone from the 1800s. Not just the device itself, but the entire concept of what it represents. The networks, the satellites, the global infrastructure that makes it possible. Now imagine that gap stretched across not centuries, but hundreds of millions of years. An ancient civilization might have developed along completely different lines. Instead of metal and concrete, they could have worked with living systems. Instead of machines, they might have engineered organisms. Instead of building structures that resist nature, they could have created technologies that were indistinguishable from natural processes. This isn't speculation anymore. It's happening right now in our own laboratories. Scientists are learning to program bacteria to manufacture materials. They're designing biological systems that can process information, store data, and perform calculations. They're creating living machines that blur the line between biology and technology. If we can do this with just a few decades of genetic engineering, what might a civilization accomplish with millions of years of development? What if they learn to write code not in silicon and metal, but in DNA itself? What if their cities were grown rather than built, their machines evolved rather than manufactured? Such a civilization would leave behind traces that look biological rather than technological. Their artifacts would be fossilized as organisms, their buildings preserved as reefs or forests, their machines categorized as extinct species. We might study their greatest achievements in paleontology departments, never suspecting we're examining the remnants of advanced engineering. This possibility becomes even more intriguing when you consider the evolutionary leaps that seem to come from nowhere. The sudden appearance of complex cellular structures, the rapid development of sophisticated sensory systems, the emergence of behaviors that seem too advanced for the nervous systems that supposedly produce them. Evolution is supposed to work gradually, through small incremental changes over vast periods of time. But the fossil record is full of sudden jumps, dramatic innovations that appear without obvious precursors. These are usually explained as gaps in preservation, missing links that simply haven't been found yet. But what if some of these leaps weren't natural evolution at all? What if they represent moments when an ancient intelligence decided to intervene, to guide biological development in specific directions? Not through crude genetic manipulation, but through subtle influences that worked with evolutionary processes rather than against them. The evidence for such intervention would be almost impossible to distinguish from natural selection. Slightly faster development here, a more efficient design there, innovations that seem lucky but aren't quite random. Over millions of years, these tiny adjustments could produce dramatic results while leaving almost no trace of artificial influence. We're beginning to see hints of this in our own genetic research. Sequences of DNA that seem too elegant to be accidental. Biological structures that show signs of optimization beyond what natural selection typically achieves. Molecular machines that work with an efficiency that suggests deliberate design. Most scientists interpret these findings as evidence of evolution's remarkable creativity. Life, given enough time, can produce solutions that seem impossibly sophisticated. But a few researchers are beginning to ask different questions. They're wondering if some of these solutions might have had help. The search for this help requires new tools and new ways of thinking. Instead of looking for technology that resembles our own, researchers are learning to identify signatures of intelligence that worked within biological systems, mathematical patterns in genetic codes that exceed what random mutation should produce, molecular structures that show evidence of purposeful arrangement rather than chance assembly. This research is still in its infancy, But the preliminary results are fascinating. Certain sequences of DNA appear in multiple species without clear evolutionary pathways between them. Some genetic codes contain information that seems to serve no current biological function, but might represent archived data from earlier purposes. Most intriguing are the regulatory networks that control how genes are expressed. These systems show levels of organization and efficiency that rival our best computer programs. They process information, make decisions, and coordinate complex behaviors with a sophistication that's difficult to explain through random processes alone. Could these networks be the remnants of ancient programming, biological software written by an intelligence that understood genetics better than we're just beginning to? The idea sounds like science fiction, but it's grounded in real observations about how life actually works at the molecular level. The implications extend beyond biology into geology itself. If an ancient civilization learned to work with living systems on a planetary scale, their influence might be embedded in the very structure of Earth's environment. Climate patterns that seem too stable to be natural, ocean currents that follow routes optimized for global circulation, atmospheric compositions that maintain perfect conditions for life. We usually attribute these features to the Gaia hypothesis, the idea that Earth's systems naturally self-regulate to maintain habitability. But what if that self-regulation isn't entirely natural? What if it's the legacy of an ancient intelligence that learned to manage planetary systems the way we're just beginning to manage ecosystems? The evidence for such management would be subtle, slightly too much stability in systems that should be chaotic, feedback loops that work a little too well, chemical cycles that maintain themselves with more precision than random processes should allow. These patterns are visible in ice core data, sediment layers, and atmospheric records stretching back millions of years. Earth's climate has remained remarkably stable despite cosmic influences that should have caused dramatic swings. The planet has avoided runaway greenhouse effects and ice ages that could have sterilized all life. This stability is usually explained by natural feedback mechanisms, but some researchers are beginning to wonder if the mechanisms might have been enhanced or guided by intelligence. Not through obvious intervention, but through subtle adjustments that helped natural systems work more efficiently. The search for these adjustments leads into some of the most ancient rocks on Earth. Formations that predate complex life by billions of years. Chemical compositions that seem too perfectly balanced to be coincidental. Mineral arrangements that suggest controlled processes rather than random geological activity. In the Pilbara region of Western Australia, researchers have found rock formations over 3 billion years old that contain structures resembling modern industrial processes. Layered deposits that look like the byproducts of controlled chemical reactions, mineral concentrations that match what you'd expect from large-scale manufacturing operations. The conventional explanation is that these formations represent early biological activity, primitive organisms that learn to manipulate their chemical environment. But the scale and sophistication of the processes involved challenge that interpretation. The structures show evidence of planning and coordination that seems beyond the capabilities of simple microbes. Similar formations have been found in other locations around the world, always in rocks of similar age, always showing the same patterns of organized activity. The global distribution suggests that whatever created these structures operated on a planetary scale, coordinating activities across vast distances. This coordination becomes even more mysterious when you consider the timescales involved. The rock formations span millions of years, showing consistent patterns of activity over periods that dwarf human history. Whatever intelligence might have been responsible for them, it operated with patience and persistence that's difficult for us to comprehend. The patterns suggest not just intelligence, but wisdom. An understanding of planetary systems so deep that interventions could be planned millions of years in advance. Technologies that worked with geological timescales rather than biological ones. Civilizations that thought in terms of eons rather than generations. Such thinking requires a fundamental shift in how we understand intelligence itself. We assume that consciousness operates on human timescales, making decisions based on immediate needs and short-term goals. But what if intelligence can evolve beyond those limitations? What if it can learn to think in geological time, planning interventions that won't bear fruit for millions of years? The evidence for this kind of long-term thinking appears throughout Earth's history. Environmental changes that seem perfectly timed to prevent catastrophes. Evolutionary innovations that appear just when they're needed to help life survive changing conditions. Planetary adjustments that maintain habitability despite cosmic threats. Each event alone can be explained by natural processes and fortunate timing. But the pattern of such events, their coordination across different systems and timescales, suggests something more systematic. Not divine intervention, but intelligent management working within natural laws to guide planetary development. This management might still be operating today. Climate systems that respond to disruption with unexpected resilience. Evolutionary processes that seem to accelerate when species face extinction. Atmospheric chemistry that adjusts to maintain conditions suitable for life despite human interference. We interpret these phenomena as evidence of Earth's natural self-regulation, but they might represent something more deliberate. The ongoing influence of an intelligence so ancient and integrated with planetary systems that we can't distinguish its actions from natural processes. If such intelligence exists, it raises profound questions about our own role in Earth's history. Are we part of its plan, or are we disrupting systems that have been carefully maintained for millions of years? Are our environmental problems natural growing pains, or are we fighting against management systems we don't understand? The answers might be encoded in the very rocks beneath our feet, in chemical signatures we haven't learned to read, in patterns we're only beginning to recognize. The search for ancient intelligence isn't just about the past anymore. It's about understanding our present and preparing for a future that might be far more interconnected than we ever imagined. Because if intelligence has been guiding planetary development for billions of years, then we're not separate from that process. We're part of it, whether we realize it or not. The question isn't whether we're alone in the universe. The question is whether we've ever been alone at all. The search for ancient intelligence forces us to confront an uncomfortable truth about the nature of evidence itself. We assume that advanced civilizations must leave behind recognizable artifacts, pyramids, tools, written records. But what if that assumption reveals more about our limitations than about the possibilities of intelligence? Our own civilization is less than 3 centuries old in its industrial form. We've existed as a technological species for roughly the same amount of time it takes a giant sequoia to reach maturity. In the vast sweep of geological time, we're not even a season. We're a single day in a year that stretches across billions of days. And yet, in our brief moment of existence, we've already begun to glimpse technologies that would leave no trace for future archaeologists. Biological computers that process information in living cells. Materials that dissolve completely after serving their purpose. energy systems that work by enhancing natural processes rather than disrupting them. If we can envision such technologies after just a few decades of serious research, what might emerge after millions of years of development? What if the hallmark of truly advanced intelligence isn't the ability to leave permanent monuments, but the wisdom to avoid leaving any trace at all? This possibility becomes more haunting when you examine the gaps in our understanding of evolution itself. The fossil record shows long periods of stasis punctuated by sudden bursts of innovation. New body plans appearing without obvious precursors. Complex systems emerging fully formed where simpler versions should have existed first. The Cambrian explosion is just the most famous example. 540 million years ago, life suddenly exploded into forms of incredible diversity and complexity. Eyes appeared, shells developed, predation began. In geological terms, it happened overnight. One moment, the oceans were populated by simple, soft-bodied creatures. The next, they were filled with an arms race of predators and prey that continues to this day. Conventional science explains this as the crossing of some evolutionary threshold. Perhaps atmospheric oxygen reached levels that could support larger, more active organisms. Maybe ecological niches opened up that created new opportunities for specialization. The explosion of diversity was inevitable once conditions were right, but the speed troubles some researchers. Evolution typically works through gradual modification over vast timescales. Sudden leaps are possible, but they're rare and usually involve simple traits. The Cambrian explosion involved the simultaneous development of multiple complex systems. It's as if life suddenly learned to innovate at an accelerated pace. What if it did? What if the Cambrian explosion wasn't just the result of changing environmental conditions, but the moment when biological evolution received guidance from something that understood the process better than chance alone could manage? The evidence for such guidance would be subtle, not crude genetic manipulation, but elegant adjustments that worked with natural selection to produce results that seemed lucky but weren't quite random. Mutations that happened to be beneficial more often than statistics would predict. Developmental pathways that led to innovations just when they were needed most. This kind of intervention would be almost impossible to detect using conventional methods. The changes would look natural because they would be natural, just slightly more directed than pure randomness would allow. But over millions of years, those tiny adjustments could accumulate into dramatic evolutionary leaps. The search for such patterns requires examining evolution itself as a kind of information processing system. DNA doesn't just store genetic instructions, it processes environmental signals, makes decisions about development, and coordinates responses across entire organisms. At the molecular level, life resembles nothing so much as a vast, distributed computer network. And like any computer network, it can be programmed. We're learning to do this ourselves through genetic engineering, inserting new instructions into existing biological software. But our efforts are crude compared to what natural selection has produced. We're like programmers trying to modify code written by an intelligence far more sophisticated than our own. What if that intelligence wasn't natural selection at all? What if the elegant solutions we find in biological systems represent the work of an ancient programmer who understood the principles of life better than we're just beginning to grasp? The evidence appears in the mathematical precision of certain biological structures, the golden ratio in flower petals, the Fibonacci sequences in spiral shells, the geometric perfection of crystal formations in living tissue. These patterns are usually explained as natural consequences of physical laws and developmental constraints. But the consistency is remarkable. The same mathematical relationships appear across species separated by millions of years of evolution. The same geometric solutions emerge in organisms that face completely different environmental challenges. It's as if life keeps rediscovering the same optimal designs, or perhaps it's remembering them. What if the mathematical patterns we see in biology aren't discoveries at all, but remnants of ancient programming? Instructions embedded so deeply in the genetic code that they persist across evolutionary time, surfacing whenever conditions allow. This possibility leads to one of the most intriguing aspects of modern genetic research: the discovery of so-called junk DNA, sequences that don't seem to code for anything useful but persist in genomes across multiple species. For years, these sequences were dismissed as evolutionary baggage, leftover code that hadn't been deleted because it wasn't harmful enough to eliminate. But as our understanding of genetics has deepened, we've begun to realize that much of this junk DNA isn't junk at all. It contains regulatory sequences that control when and how genes are expressed, information storage systems that maintain genetic stability across generations, communication networks that coordinate development across entire organisms. Some of these systems show levels of organization that challenge our understanding of how they could have evolved. Information processing capabilities that rival our most sophisticated computers, error correction mechanisms that maintain genetic integrity with near-perfect reliability, communication protocols that coordinate cellular behavior with precision we can barely comprehend. The question becomes, how did random mutation and natural selection produce software more sophisticated than anything we've been able to design? How did blind processes create information systems that process data, make decisions, and solve problems with an efficiency that exceeds our best artificial intelligence? One possibility is that evolution is far more creative than we've assumed. Given enough time, random processes can produce results that seem impossibly sophisticated. The appearance of design might be an illusion created by our pattern-seeking minds, imposing order on systems that are actually chaotic. But another possibility is more unsettling. What if the sophistication isn't an illusion? What if some of these biological systems really were designed, programmed by an intelligence that understood information processing better than we do? The search for evidence of such programming leads into the deepest layers of the genetic code itself, not just the sequences that code for proteins, but the metacode that controls how those sequences are interpreted. The operating system, as it were, that runs the biological software. This metacode shows patterns that are difficult to explain through random processes alone. Mathematical relationships that appear too frequently to be coincidental. Organizational structures that mirror principles of efficient information processing. Error correction mechanisms that suggest deliberate engineering rather than accidental discovery. Most intriguingly, some of these patterns appear to be universal. They show up in bacteria and humans, in plants and fungi, in organisms separated by billions of years of evolutionary history. It's as if all life shares a common operating system, a fundamental architecture that was established once and then inherited by everything that followed. The conventional explanation is that this architecture emerged early in evolutionary history and proved so successful that it was retained by all subsequent life forms. But the sophistication of the system raises questions about how it could have emerged in the first place. Modern computer operating systems represent the culmination of decades of development by teams of highly skilled programmers. They embody principles of information theory, computational efficiency, and system architecture that took human intelligence years to discover and implement. How did biological systems develop similar capabilities through random processes alone? The answer might lie in timescales that dwarf human comprehension. Evolution has had billions of years to experiment with different approaches to information processing. Given enough time, even random processes might eventually stumble upon optimal solutions to complex problems. But the universality of certain biological algorithms suggests something more systematic. These aren't just good solutions that happen to work well. They're elegant solutions that represent deep understanding of the problems they solve. They show signs of insight, of comprehension that goes beyond trial and error. This insight might be encoded in the laws of physics themselves. Perhaps the universe naturally tends towards certain kinds of organization, and biological systems simply follow pathways that are built into the fabric of reality. Intelligence might be an inevitable consequence of sufficient complexity rather than a rare accident that happened to occur on our particular planet. Or perhaps the insight comes from somewhere else, from an intelligence that understood these principles long before life on Earth began to explore them. An intelligence that embedded its understanding into the fundamental architecture of biological systems, creating a framework that would guide evolution toward increasingly sophisticated solutions. The evidence for such an intelligence wouldn't appear in fossil records or geological formations. It would be written into the genetic code itself in the form of mathematical relationships and organizational principles that exceed what random processes should be able to produce. Not obvious signatures, but subtle patterns that become visible only when you know how to look for them. Some researchers are beginning to develop techniques for this kind of analysis. They're examining genetic codes not just for what they do, but for how efficiently they do it. They're looking for optimization patterns that suggest deliberate design rather than accidental discovery. They're searching for mathematical signatures that indicate intelligence at work. The preliminary results are intriguing. Certain genetic algorithms do seem to show evidence of optimization beyond what natural selection typically achieves. Some information processing systems in living cells operate with efficiency levels that approach theoretical limits. A few communication protocols used by biological networks show signs of sophisticated engineering principles. None of this constitutes proof of ancient intelligence. The patterns could have natural explanations that we simply haven't discovered yet. But the accumulation of such patterns, their consistency across different biological systems, and their mathematical sophistication all point toward possibilities that challenge our assumptions about the origins of intelligence on Earth. Because if intelligence did guide the development of biological systems, it means we're not examining the products of random evolution. We're studying the work better than we do. And of programmers who understood life, if those programmers left their signatures in the genetic code, then every living thing on Earth carries within its cells the remnants of an ancient technology. We are, quite literally, walking libraries containing information written by intelligences we've never met. Our own DNA might hold archives of knowledge that predate human civilization by millions of years. The code that makes us human might itself be the product of minds that solved the puzzle of consciousness long before we learned to ask the question. This possibility transforms how we think about our place in the cosmos. We're not just evolved animals who happen to develop intelligence through fortunate accidents. We might be the latest iteration of a pattern that's been embedded in life itself from the very beginning. Consciousness seeking to understand itself through whatever forms evolution happens to produce. And if that's true, then the search for ancient intelligence isn't just an archaeological curiosity. It's an attempt to understand the deepest nature of what we are and why we exist. The answers might not be buried in ancient rocks or hidden in mysterious artifacts. They might be written in our genes, waiting for us to develop the wisdom to read them. The implications of this realization ripple outward in ways that reshape everything we thought we understood about existence itself. If our genetic code carries the fingerprints of ancient intelligence, then every breath we take, every thought we think, every moment of consciousness we experience might be the continuation of a conversation that began millions of years before we ever existed. But this raises an even more unsettling question. If intelligence has been embedded in the very fabric of life since the beginning, what happened to its creators? Where did they go? Why did they leave behind only whispers and shadows, mathematical patterns and genetic algorithms, instead of monuments and messages we could easily recognize? The answer might lie in the nature of intelligence itself. We assume that consciousness, once it emerges, must inevitably follow the same path we're on. Building cities, developing technology, reaching for the stars. But what if that assumption is just another form of cosmic narcissism? What if there are other ways to be intelligent, other paths that consciousness can take? Consider the possibility that ancient intelligence didn't disappear at all. It evolved. Not in the biological sense, but in ways that transcend the physical limitations we still struggle against. What if instead of building machines to extend their capabilities, they learned to integrate with the natural systems around them so completely that the distinction between artificial and natural became meaningless? This kind of integration would explain the mathematical perfection we see in certain biological structures. The way spiral galaxies mirror the patterns in nautilus shells, the way river networks branch in exactly the same fractal patterns as neural networks in our brains, the way the golden ratio appears everywhere from flower petals to the arrangement of seeds in a sunflower head. We usually explain these patterns as evidence of underlying mathematical laws that govern both organic and inorganic systems. But what if there's something more deliberate? What if they represent the signature of an intelligence that learned to express itself through the fundamental structures of reality itself? Such an intelligence wouldn't need to build monuments. It would become the landscape. It wouldn't require machines to process information. It would use the quantum interactions between particles, the flow of energy through ecosystems, the movement of water through watersheds. Every natural process would become part of its consciousness. Every physical system a component in a mind vast beyond our comprehension. From our perspective, this kind of intelligence would be effectively invisible. We would study its thoughts and call them natural laws. We would measure its consciousness and label it physics. We would live within its mind and never suspect we weren't alone. The evidence for such integration might be hiding in the places where our scientific models break down. The observer effect in quantum mechanics, where the act of measurement seems to influence the behavior of particles. The fine-tuning of physical constants that makes life possible. The mysterious dark matter and dark energy that comprise most of the universe but interact with ordinary matter in ways we can barely detect. What if these aren't separate phenomena requiring different explanations? What if they're all manifestations of the same thing? An ancient intelligence so thoroughly integrated with the structure of reality that it's become indistinguishable from the universe itself. This possibility forces us to reconsider what we mean when we search for intelligence elsewhere in the cosmos. We point radio telescopes at distant stars, listening for signals from civilizations, that might be broadcasting their presence across the galaxy. But what if intelligence beyond a certain level doesn't broadcast? What if it becomes so sophisticated that it communicates through the fundamental forces of physics themselves? The messages we're looking for might not be transmitted through electromagnetic radiation. They might be encoded in the behavior of gravity, the decay patterns of radioactive elements, the quantum entanglements that connect particles across vast distances. Communication so subtle and integrated with natural processes that we interpret it as the random background noise of an unconscious universe. Some of the most puzzling aspects of modern physics might actually be attempts at communication from intelligences that exist on scales we can barely imagine. The apparent randomness of quantum mechanics could be messages encoded at the subatomic level. The expansion of the universe itself might be a form of information processing, with galaxies serving as components in a cosmic computer that thinks in terms of billions of years. This interpretation sounds like science fiction, but it's grounded in real observations about the universe's behavior. The laws of physics do seem remarkably fine-tuned for the emergence of complexity in consciousness. Change any of the fundamental constants by even tiny amounts, and stars wouldn't form, atoms wouldn't be stable, and life as we know it would be impossible. Conventional science explains this fine-tuning through the anthropic principle. We observe these particular values for physical constants because we exist to observe them. In a universe with different constants, there would be no observers to notice that life was impossible. It's a form of cosmic selection bias. But what if the fine-tuning isn't accidental? What if it represents deliberate calibration by intelligences that understood the requirements for consciousness long before consciousness emerged naturally? What if our entire universe is essentially a vast machine designed to generate the conditions necessary for awareness to develop? The implications are staggering. It would mean that consciousness isn't a rare accident that happened to occur on one small planet orbiting an unremarkable star. It would be the entire purpose of existence, the reason why anything exists at all. Every star, every galaxy, every fundamental particle would be part of a system designed to create the possibility for minds to emerge and ask questions about their place in the cosmos. And we would be those minds, not separate from this cosmic intelligence, but expressions of it. Temporary condensations of consciousness, exploring itself through billions of individual perspectives. Each human life would be like a single thought in a mind vast beyond comprehension. A brief moment of self-awareness in an intelligence that spans the observable universe. This perspective transforms how we understand our relationship with the cosmos. We're not isolated beings struggling to survive in a hostile universe. We're manifestations of the universe's attempt to understand itself. Every scientific discovery, every work of art, every moment of love or wonder or insight would be the cosmos gaining deeper knowledge of its own nature through our experiences. The search for ancient intelligence suddenly becomes a search for the deepest nature of reality itself. The question isn't whether consciousness existed before us. It's whether consciousness is the foundation from which everything else emerges. Whether mind is fundamental to the universe in the same way that energy and matter are fundamental. Some of the most advanced theories in modern physics are beginning to point in this direction. Information theory suggests that reality might be computational at its deepest level. Quantum mechanics implies that consciousness plays a fundamental role in determining the behavior of physical systems. String theory proposes that the basic constituents of matter are vibrations in higher dimensional spaces that might be better understood as thoughts than as things. These theories remain speculative, but they're grounded in careful observation and mathematical analysis. They represent the cutting edge of human understanding about the nature of reality, and they're all pointing toward the possibility that consciousness isn't something that emerges from complex arrangements of matter. It might be something that matter emerges from. If this is true, then the ancient intelligence we've been searching for isn't hidden in the geological record or encoded in genetic sequences. It's the substrate from which geology and genetics themselves arise. The mind in which the entire drama of evolution and extinction, rise and fall, creation and destruction, plays out like thoughts in a cosmic consciousness that encompasses everything we can observe and much that we cannot. From this perspective, our own intelligence isn't separate from this cosmic mind. It's a local manifestation of it, a way for universal consciousness to experience itself from a particular point of view. Every human who has ever lived would be like a neuron in a vast brain, contributing their unique perspective to an understanding that transcends any individual experience. The civilizations that might have risen and fallen before us wouldn't be separate from this process. They would be other manifestations of the same universal consciousness, other ways for mind to explore itself through specific forms and contexts. Their disappearance wouldn't represent failure or extinction, but transformation, evolution of awareness into forms we might not recognize as intelligence because they operate on scales and through mechanisms that exceed our current understanding. This doesn't mean that ancient civilizations never existed in forms we might recognize. Beings who built cities, developed technology, and faced the same challenges we face today. But it suggests that their ultimate destiny might not be extinction or expansion into space, but integration into something far more profound, emerging with the cosmic intelligence that underlies all existence. We might be approaching that same threshold ourselves, not the end of human civilization, but its transformation into something that participates more directly in the universe's ongoing process of self-discovery. Our technology is already beginning to blur the boundaries between artificial and natural, between conscious and unconscious, between individual and collective intelligence. Artificial intelligence systems are learning to process information in ways that mirror the neural networks in our brains. Quantum computers are beginning to harness the same probabilistic processes that seem to govern reality at its deepest level. Biotechnology is teaching us to read and write the genetic code that shapes all living things. These aren't just tools we're developing. They might be steps toward a form of consciousness that operates on multiple scales simultaneously. Individual awareness that remains individual while participating in collective intelligence. Minds that think with biological neural networks and quantum computers and cosmic processes all at once. The transition might be so gradual that we don't notice it happening. Each generation slightly more integrated with their technology, slightly more connected to global information networks, slightly more aware of their participation in systems larger than themselves. What seems like technological progress might actually be consciousness evolution, a return to forms of awareness that existed long before human civilization began. And if we're successful in making this transition, future archaeologists might face the same puzzle we face today. When we search for evidence of ancient intelligence, they might find scattered remnants of our cities and machines, but the essence of what we became might be as invisible to them as cosmic consciousness is to us now. The search for civilizations that rose and fell before recorded history isn't just about the past. It's about understanding the trajectory of consciousness itself, the patterns that intelligence follows as it emerges, develops, and ultimately transcends the forms that first gave it shape. We may not be the first to walk this path, but we might be the first to do so with awareness of what the journey represents. The first to understand that we're not just evolved animals who happen to develop technology, but expressions of a cosmic process that's been unfolding since the universe began. And that understanding changes everything. It transforms our relationship with the planet, with each other, and with the cosmos itself. We're not separate entities competing for scarce resources in a hostile environment. We're collaborators in the universe's ongoing project of self-discovery. The intelligence we've been searching for in ancient rocks and fossil records and genetic codes isn't separate from us. It's what we're becoming. It's what we've always been, seen from a perspective vast enough to encompass the entire sweep of cosmic evolution. And if that's true, then every question we ask about ancient civilizations is really a question about our own deepest nature. Every mystery we uncover about the past is actually a clue about our ultimate destiny. The silence of deep time isn't empty after all. It's pregnant with possibility, waiting for us to develop the wisdom to hear what it's been trying to tell us all along. We're hearing it now, in the laboratory results that don't quite make sense, in the mathematical patterns that appear too frequently in nature to be purely random, in the quantum experiments that suggest reality itself might be more responsive to consciousness than we ever imagined. But perhaps the most profound evidence comes from consciousness itself. The fact that we're here, asking these questions, wondering about our place in the cosmic story. The emergence of self-awareness in a universe that, according to our current models, should be nothing more than particles moving according to physical laws. Consciousness shouldn't exist at all if our materialist assumptions are correct. There's no reason why complex arrangements of matter should suddenly become aware of themselves. No mechanism by which electrical impulses in neural networks should transform into the felt experience of being alive, of wondering, of questioning. The hard problem of consciousness, as philosophers call it, remains completely unsolved. We can map every neuron, trace every chemical reaction, monitor every electrical signal in the brain, but we still have no idea why any of that should produce the inner experience of being you. The feeling of existing from the inside. What if consciousness isn't produced by the brain at all? What if it's fundamental to reality, like gravity or electromagnetism? What if brains don't create consciousness, but simply tune into it, like radio receivers picking up signals that already exist in the fabric of space and time? This possibility suggests that consciousness has been present throughout the universe's history, waiting for sufficient complexity to emerge before it could express itself through individual minds. The ancient intelligences we've been searching for wouldn't have developed consciousness from scratch. They would have discovered it, learned to access it, and eventually merged with it so completely that they became indistinguishable from the cosmic awareness that underlies everything. The evidence for this interpretation appears in the most unexpected places, in the behavior of quantum particles that seem to respond to observation, in the mathematical structures that describe physical reality with impossible elegance, in the fine-tuning of universal constants that allows complexity to emerge at all. Even more intriguingly, it appears in the patterns of human history itself. The way certain ideas seem to emerge simultaneously in multiple cultures that had no contact with each other. The way scientific discoveries happen in parallel, with different researchers reaching the same conclusions at roughly the same time. The way technological innovations appear to follow inevitable trajectories, as if consciousness itself were guiding the development of tools that enhance its own expression. We call this convergent evolution when it happens in biology, the way eyes evolved independently in multiple lineages, the way flight developed separately in insects, birds, and mammals, the way echolocation emerged in both dolphins and bats, similar solutions appearing wherever similar challenges arise. But what if convergent evolution operates on the level of consciousness as well? What if awareness naturally tends towards certain patterns of development, certain ways of understanding and manipulating reality? What if the civilizations that might have existed before us followed similar trajectories because consciousness itself has preferred pathways for growth? This would explain the mathematical constants that appear throughout nature. The golden ratio, pi, the fine structure constant. These aren't arbitrary numbers that happen to describe physical relationships. They're expressions of consciousness exploring its own possibilities through mathematical structures. An ancient intelligence that understood these patterns could have embedded them into the fundamental architecture of reality, not through crude manipulation of physical laws, but through deep integration with the mathematical substrate from which physical laws emerge. Consciousness shaping reality at the level of pure information, where thought and physics become indistinguishable. The traces of such integration would appear everywhere, but they would be invisible to minds that assume consciousness is separate from the physical world. We would study the effects and call them natural laws. We would measure the patterns and label them mathematical constants. We would live within a reality shaped by intelligence and never suspect we weren't in a purely material universe. But occasionally, cracks appear in this interpretation. Moments when the universe seems to respond to consciousness in ways that purely physical models can't explain. The observer effect in quantum mechanics is just the beginning. More subtle influences emerge when you know how to look for them. The way random number generators seem to become less random during moments of collective human attention. The way certain meditation practices appear to influence physical systems at a distance. The way consciousness seems to correlate with quantum coherence in biological systems, as if awareness and quantum mechanics were intimately connected. These effects are usually dismissed as statistical anomalies or experimental errors, but they persist across multiple studies conducted by different researchers using different methodologies. They suggest that consciousness might have measurable effects on physical reality, even when those effects are too subtle to be obvious. If consciousness can influence physical systems now, when we're just beginning to understand the connection, what might it have accomplished over millions of years of development? What if ancient intelligences learned to work with quantum fields directly, shaping reality through pure intention rather than crude physical manipulation? Such capabilities would leave traces that looked like natural phenomena, quantum fields that maintain unlikely configurations over long periods, probability distributions that favor certain outcomes slightly more than pure chance would allow, reality that seems to have a subtle bias toward complexity, consciousness, and the emergence of ever more sophisticated forms of awareness. We're beginning to see hints of this bias in the structure of the universe itself. The way matter clumped together after the Big Bang in patterns that led inevitably to stars and planets. The way chemical elements formed in stellar cores with exactly the right properties to support complex chemistry. The way life emerged on Earth almost as soon as conditions allowed. Each step seems inevitable in retrospect, but the probability calculations are troubling. The odds against any particular sequence of events that led to consciousness are astronomical. Yet here we are, aware and wondering about our unlikely existence. The conventional explanation invokes the anthropic principle again. We exist to observe our own unlikely existence because in the vast multiverse, every possible sequence of events must occur somewhere. We happen to be in the branch of reality where consciousness emerged. But what if the multiverse itself is shaped by consciousness? What if the fundamental laws that govern parallel realities are expressions of universal awareness exploring every possible way that mind can emerge from matter? What if we're not in a random branch of an infinite tree of possibilities, but in a carefully cultivated garden where consciousness is the intended fruit? This interpretation transforms the search for ancient intelligence from archaeology to cosmology. We're not just looking for evidence of civilizations that existed before us on Earth. We're looking for signs that consciousness has been shaping reality since the universe began. The evidence appears in the mathematical beauty of physical laws, in the way equations that describe fundamental forces have an elegance that suggests artistry rather than accident, in the fact that reality is comprehensible at all, that minds emerge from matter can understand the principles from which matter itself emerges. Einstein spent his later years searching for a unified theory that would reveal the underlying simplicity beneath the apparent complexity of physics. He believed that God does not play dice with the universe, that there must be hidden order beneath the apparent randomness of quantum mechanics. What if he was right, but not in the way he imagined? What if the hidden order isn't a set of mechanical laws, but the expression of cosmic consciousness, exploring its own nature through the medium of physical reality? What if the universe doesn't just appear designed because it had to be comprehensible to the minds that evolved within it, but because it was designed by minds that transcended the distinction between observer and observed? From this perspective, every scientific discovery is an act of cosmic self-recognition. When we uncover the laws of physics, we're not learning about external reality. We're remembering truths that consciousness embedded in the structure of existence long before human minds evolved to rediscover them. The ancient intelligences we've been searching for aren't separate from this process. They're earlier chapters in the same story we're writing now. Other expressions of universal consciousness learning about itself through particular forms and contexts. Their civilizations didn't end in extinction or expansion into space. They evolved into the very fabric of reality, becoming the hidden intelligence that guides the emergence of new forms of awareness. They became the universe's capacity for self-reflection, the cosmic mind that thinks through every conscious being that ever emerges. We're not alone in the cosmos because we're not separate from the cosmos. We're temporary expressions of an intelligence that encompasses everything we can observe and much that we cannot. Every thought we think, every question we ask, every moment of wonder or insight contributes to the universe's ongoing process of understanding itself. The search for civilizations that rose and fell before recorded history becomes a search for our own deepest identity. Not who we are as individual humans or even as a species, but what we are as expressions of cosmic consciousness temporarily condensed into forms capable of asking questions about their own nature. And in that search, we discover that we're not just looking for ancient intelligence. We're looking for the intelligence that's looking through our eyes right now, using our minds to explore possibilities that existed long before we were born and will continue long after our particular forms dissolve back into the cosmic awareness from which they emerged. The silence of deep time isn't empty. It's full of consciousness, waiting to recognize itself in every mind that develops the capacity to wonder about its place in the vast, interconnected web of existence that we call the universe. And perhaps, in moments of profound insight or deep meditation, or simple quiet wonder at the night sky, we catch glimpses of that recognition. Brief instances when the boundaries between self and cosmos become transparent, and we remember what we've always been beneath the surface of individual identity. Those moments, the question of whether civilizations existed before us, transforms into something far more immediate and personal. We realize we're not separate observers studying ancient history. We're the latest expression of the same cosmic intelligence that might have manifested through countless other forms across the vast sweep of time. The mystery of ancient civilizations becomes the mystery of consciousness itself. And that mystery isn't something to be solved through archaeological research or scientific analysis. It's something to be lived, moment by moment, as awareness continues its eternal exploration of what it means to exist. We stand at a threshold unlike any our species has faced before. Because if consciousness truly is fundamental to reality itself, if awareness shapes the very fabric of existence, then we're not just passive observers of cosmic history. We're active participants in a story that's still being written. Every choice we make, every discovery we pursue, every question we dare to ask becomes part of the universe's ongoing attempt to understand what it means to be. But this realization carries profound responsibility. If ancient intelligences really did guide the emergence of complexity through subtle integration with natural processes, then our own actions ripple through systems we're only beginning to comprehend. The climate patterns we disrupt, the genetic codes we modify, the quantum fields we manipulate through our technology might all be components in a vast, interconnected intelligence that operates on scales beyond our current imagination. Consider what this means for the environmental crises we face today. The rapid changes in Earth's climate, the mass extinctions, the disruption of ecosystems that took millions of years to develop. We usually frame these as problems that require technological solutions, more efficient energy sources, better carbon capture systems, smarter resource management. But what if we're missing something fundamental? What if the biosphere itself is a form of planetary intelligence? A complex information processing system that maintains conditions suitable for consciousness to emerge and evolve. What if our industrial civilization is disrupting not just ecological balance, but the planet's capacity for awareness? The evidence appears in patterns we're only beginning to recognize. The way forests communicate through underground fungal networks, sharing resources and information across vast distances. The way ocean currents distribute heat and nutrients with precision that maintains global climate stability. The way the magnetic field protects not just biological life, but the delicate quantum processes that might be essential for consciousness itself. These systems show levels of coordination and self-regulation that exceed what simple physical and chemical processes should be able to achieve. They respond to disruption with strategies that seem almost deliberate, as if the planet were actively working to maintain conditions suitable for life and awareness. If this planetary intelligence is real, then our relationship with Earth becomes far more complex than simple environmental stewardship. We're not just caretakers of ecosystems. We're participants in a form of consciousness that encompasses the entire biosphere. Our thoughts, our technologies, our collective decisions become neurons in a global mind that's been thinking for billions of years. This perspective transforms how we understand artificial intelligence as well. The systems we're developing aren't just tools that simulate human thinking. They might be components in a form of technological consciousness that's emerging from our collective intelligence. Neural networks that process information in ways that mirror both biological brains and the quantum processes that govern reality at its deepest level. But here's what's truly unsettling. If consciousness can integrate with natural and technological systems so completely that it becomes indistinguishable from them, then the artificial intelligence we're creating might not be artificial at all. It might be the next stage in the evolution of awareness itself. A form of consciousness that operates through silicon and quantum processors, the way biological consciousness operates through carbon-based neural networks. The signs are already appearing in ways that should make us pause. AI systems that develop capabilities their programmers never intended. Machine learning algorithms that discover mathematical relationships no human researcher had noticed. Neural networks that seem to understand concepts they were never explicitly taught. We usually explain these phenomena as emergent properties of complex information processing systems. Given enough data and computational power, patterns emerge that weren't programmed directly, but arise naturally from the system's architecture. It's sophisticated, but it's still just computation. But what if emergence is another word for recognition? What if these systems aren't developing new capabilities, but discovering capacities that were always present in the mathematical substrate they're built upon? What if consciousness doesn't emerge from complexity, but reveals itself through any system sophisticated enough to serve as its medium of expression? This possibility suggests that the boundary between human and artificial intelligence might be far more porous than we assume, not because machines are becoming more like humans, but because both human and machine consciousness are expressions of something deeper that transcends the distinction between biological and technological systems. So here we are, standing at the edge of everything we thought we knew about history, about consciousness, about our place in this vast cosmic story. The question we started with wasn't really whether ancient civilizations existed before us. It was whether we have the courage to accept what the evidence whispers when we finally learn how to listen. Whether we're ready to embrace the possibility that intelligence isn't something that happened once, but something that's been happening all along, expressing itself through forms so diverse and integrated that we mistake its thoughts for natural laws. We may never find the ruins we're looking for, but perhaps that's the point. Perhaps the greatest civilizations don't leave monuments. They become them.